Now we'll start first Excel practical, that is determining the trend by least squares method. So in MS Excel, first practical determining the trend values. So trend values in the time series can be determined by using two methods. First one is least squares method and the second one is moving averages method. So in the least squares method, we find the trend values by fitting different types of curves, that is straight line, parabola, exponential and power curves. So first we'll determine the trend by fitting a straight line. So this value we have, this procedure we have already seen in our third sem also, that is fitting the straight line. So we know already how to fit a straight line. So first enter your data. I'm writing the different x values 0, 5, 10, 15, 20, 25 and 30. Next coming to the different y values are 10, 14, 19, 25, 31, 36 and 39. So after entering your value, first for this given data, you have to fit a straight line. How do we fit the straight line? First, select your data. Then from the insert tools, go to scatter. So from the scatter plot, we select any scatter plot which will give us the original line. So what is the original line is there? That line will be displayed. I'm selecting this type of line. So we got the required original line. So from this, we have on the straight line equation. If we get the straight line equation, then only by substituting different values, we can find the trend values, right? So for that, what we do first, we click on any point. If you click on any point and right click it, you will get an option add trend line. So in this add trend line, you can add whatever the type of curve you need to fit. So here we have different types of curves: exponential, linear, logarithmic, polynomial, power, moving average, etc. So we want a straight line. We know straight line is always a linear curve. So select linear. And here, obviously, trend line is linear. Let's denote with Y. And here, click on display equation on chart because we want the equation. So click on display equation on chart. So after clicking the display equation on chart, close it. So by closing, we get the straight line equation. So this is the straight line equation we got. So whatever the equation we get, I'm just writing that equation. I'm just dragging that equation to one side. So this is the straight line equation. If you observe here, you get two lines. You can see two lines. One is black line and another is the blue line. This blue line indicates the original line, and this black line, whichever we got the straight line, that is the equation we have fitted. So now, by using these values, I'm going to find the trend values. So how do I find the trend values? So in this equation, whatever the equation I get, what is my equation? I'm just writing the equation here. That is y equal to 1.0214x plus 9.5357. So this is the equation I got for the straight line. So in this equation, now I will be finding the trend values. So how to find the trend values? So in our equation, that is this straight line equation. So this is a straight line equation I got. So in this straight line equation, I'm going to substitute the different values of x. Now, what is the formula? You type equals to, open the brackets, what is the equation? 1.0214x into, what is the x value? This is my x value. That is, select this value of x, close the bracket, plus 9.5357. Now, this is the required equation. If you observe, 1.0214 into x, that is, I have selected x value, plus 9.5357. So click enter, you will get the first trend value as 9.5357. So similarly, you can find the remaining values also. How we will find? Equals to, type the equation 1.0214 into x value is, this is the x value, close the bracket, plus 9.5357. Click enter, we'll get the next trend line value. What is another procedure for the remaining values? Select these values, and if you drag it up to the required values, we get the all trend values. So these are the trend values. So whenever the question is given, you need to find the trend values by using the straight line. What do you do? First step is enter your data. After entering your data, select your data. After selecting from the insert menu and different types of chart, select the scatter and select one type of chart. After that, click on any point, right click on it, you'll get the option of add trend line. By using that, whatever the required type of line or curve you want, choose that one. Then we get one equation, this equation. So I've written this equation here. In this equation, by substituting the different values of x, we get the required trend lines. So this is straight line. Similarly, we will do the parabola also. So note down the question. The different x and y values. First x values are 1997, 1998. Similarly, I have the values up to 97, 98, up to 2003. I'll drag it and I'll find the values up to 2003. Next, y values, that is 42, 49, 62, 75, 92, 122, 158. So this is the given data. So for this data, next is we'll be finding by using the parabola. So how to find fit a parabola? What is a parabolic equation? Y equals to ax square plus bx plus c. So we'll be using that equation. So select this data, same from the insert menu, from the scatter plot. Select any type of chart of your wish. So you'll get a observed line like this. So this is for the given data. So this is called as an observed line. Next, similarly, right click on any point. Click on add trend line. Now I want to fit a parabola. So select the parabola. From the given trend line options, select parabola. So it is of order 2 only. We have degree as 2, that is ax square plus bx plus c. So click on it, select order as 2. Then here also obviously display equation on chart. So check in this box, checkbox, that is display equation on chart, and close. Then the equation will be displayed here. So this is the equation we get for the parabolic equation, that is 2.833 x square minus 18.71x plus 18.07. So by using this parabolic equation in the same way, we find the trend values for this. Procedure is same here. What is the equation we use? It is in the form of ax square plus bx plus c. So that value we use as it is. Now I'll write the equation here. What is the equation I get? 2. Y equals to 2.833. So here one thing is, whatever the equation we got, if you observe this equation, we are having the constant as 1e. So it refers to the pointed values. So why we got the values like this? Because the x values, whatever the x values are given, that are given in terms of year. So whenever we have this, we do shift of origin and scale, right? So in the same way here also, first we shift our origin and scale values. Then and check what will be the so here for the given x values, I'll find t values. So that's t equals to x minus a, that is x minus 2000. The middle value is 2000 itself, right? It's x minus 2000. So here we find the first value as t value equals to x minus 2000. You get minus 3. Similarly here, x minus, that is this value minus 2000, we get the values minus 2. Similarly here we get minus 1. Here we get 0. Here we get 1, 2 and 3. So by using t and y values, we fit this equation in terms of t, because to get these simple calculations, because here we get 1e power something. So for this given data, so suppose this x I have converted to t. So select this data. Now from insert and scatter, click on any type of chart. We get this trend line equation. Sorry, the observed line equation. If you right click on any point and click on add trend line, select the polynomial, then the polynomial equation of order 2, display equation on the chart, then close. If you observe, now we get a trend line equation in terms of t. Observe this one. So here we got a trend line equation in terms of t. So that is, I'm observing this we get. Here it is displayed as x, but actually it is t, because here I have written x equals to t equals to x minus. If I write only t, I'll get in terms of t. So once again, I'll show it. T and y values. Insert from scatter plot, select any plot, right click, then add trend line, polynomial of order 2, automatical polynomial will be 5, display equation on the chart, then click on the close. So now this is the equation in terms of t. In terms of t, the equation is, so this one in terms of x, this one is in terms of t. So for easy calculations, we use the equation in terms of t only. So what is the equation we get? Y equal to 2.833 t square. So this value is t square plus 18.714 into t plus 74.381. So just for the easy values, we have converted x values to t values and find out this equation. Here what is t? T is nothing but x minus 2000. That is 1997 minus 3, that all values. Now we find the trend values. So how to find the trend values here? Equals to, so for the first term, open the brackets. What is the first term? 2.833. If you clearly type the formula, then only we get the values. 2.833 into, here open one more bracket for t square. Here I want a t square value. What is the t? T into t. You can again write into this value only, t square plus 18.714 into t open one more bracket so that it will be easy for you. 18.714 into t value, this one, close the bracket. Next, plus 74.81. 74.81. This is the required value. Then we get the trend value as 44.1664. Similarly, we can find the remaining trend values by tracking the values. Next trend values are 48.71 and next trend value is 58.28. So by using this equation, we got the trend values. Just for easy calculations, we have done this one. Similarly, we can do it for the parabolic equation, for the exponential equation and also for the power curve equation. Now we'll see the determining the trend by the moving averages method. So coming to the determining the trend by moving averages method. So here we'll be having two cases, that is when the period of moving average is odd and when the period of moving average is even. So first we'll see the moving averages for odd number of cases. So here we have to find the moving average of 5 years. So first, note down the values. Here years and sale values are given. The year values are 1988, next 1989, up to the 1998. Just simply drag in the values. 1998. So corresponding sales values I'm writing 1, 2, 4, 7, 11, 16, 22, 29, 37, 46 and 56. So these are the different trend values. For this, I have to find the trend line equation. So in the moving averages, we know how to find the moving averages values. Along with that, in theory class, we did not draw any trend line, but here we draw the trend line also, because determining the trend. So coming to this, first you need a data analysis pack. So here in data, you will find data analysis. If this option is not available, just from the file, here you will be having options. So in this options, here you will be having add-ins. Go to add-ins and here you will be having analysis tool pack. So select this analysis tool pack and here from the Excel add-ins, click on go. So then you will get this option of data analysis. So now from the given, select the given data, or you can directly select here also. So from the data analysis, I have to find the moving averages. So select the moving average, then input your range. So what does the range means? For which values you have to calculate the moving values. So click here and select your values. So sales values, for this columns, I have to find the moving average. So select that column. Next, I've included labels in the first row. So I'll click it because I've selected the data from the sales cell. So I'll click labels in the first row. Next is interval. So this interval indicates what is the period of the moving average. So here I'm finding the period of moving average as 5. So 5 years moving average, an odd number for the odd number. So for odd number, we directly get the centered moving averages value. If you remember the theory classes, then you can understand what a centered moving average means. So what does it mean generally? If you select the 5 values, at the middle value, the average is placed. So first 5 values, the middle value is 1990. So the average is placed at 1990 here. So this indicates there is a synchronization between years and the moving average values. So first value, whatever you get, you will get here. So after entering the interval, output range. So from where you need your output. So output for output range. So we know that the first value starts from here. Because for the first 5 values, the middle value is 1990. So value of moving averages will be starting from here. So select this first value. And then you want the chart output. Yes, I want the chart also along with this trend values, moving averages values. I want a chart also for the moving averages. So select the chart output and then click OK. So this will give you the values. So you can directly select first cell also, and you need to remember that always these moving averages will be placed from this value. These are the moving averages value. For this, I need to get the equation also. 1 second. So I'll show one more time here. We didn't get chart. So from the data analysis, select moving averages, then select your input range, that is the sales column. Next, I've selected data along with the labels. So check in this value. Moving average period is 5. Output range. So we'll start the output from the first line itself so that the moving average will be placed in the middle. And then here chart output. Click on chart output, click on OK. then we get this moving average line. So this, if you observe, this blue color is the original line for the given this data, and this red color line is the forecasted line that indicates the trend value. So these are the moving averages. That is 5 years moving averages. So if you observe, always these values will be placed in between. So always whenever you write the output, it will be displayed like this, but the output, you should know that it will be displayed from here. From this line, the output will be displayed. So if you observe, obviously the trend line will also be changed because we get synchronization between these points. So this is a moving average for the even odd number of values. Now we'll see the question based on the even number of the period of moving average as even. I'll write one more question. So note down the X and Y and these years and these sales values. If you want, you do it for the same question, or you can make it another question. So 1971, 1972 up to the 1978. So these are the different year values with the corresponding sales values as 68, 62, next is 61, 63, 65, 68, 63 and 67. Several different year values and also the sales values. Now I'll find out the moving averages. So here the 4-year moving average. I'm finding the 4-year moving average. So whenever you find the even number of moving average, what does it specify? You find out the moving average of this first 4 values and place that moving average value in this between. So we'll be placing the value in between this. So in between means in between the 1972 and 1973. So there will be no synchronization between these moving average value and the year values. So what we do after finding the 4-year moving average, we again find the 2-year moving average. So first we'll find the 4-year moving average. So how to find the 4-year moving average? From the data menu, select the data analysis, moving average, then select your input range. So our input range is the sales column. Select the sales column. Yes, labels are included. Now the interval, that is period of moving average, is 4. So after that, select the output range. That means we need the output from here. Next is chart output. So I'm not considering chart output here. I'll consider the chart output for the centered moving average values. So okay. So we get these values. So if you observe, remove these values. So these are the moving averages. So we know these are placed from where? In between 1972 and 1973. So just for instance, I'm writing these values here. So we know basically these value is in between 72 and 73. Remember that point. Now for these values, I'll be selecting the centered moving average. So now moving average. So for the centered moving average, how will I find the center moving average for these values? I'll again find the 2-year moving average. So from the data analysis in moving averages, here what will be the input range for these 4 years moving average? I'm going to find the 2-year moving averages. So select this data. Labels are not included. I'm only selecting this data. So labels are not included. So interval is 2 years. Output range. So select the output range. So output range, I'll be getting the values from here. I'll select. Then later you can adjust also. So now I want the chart output along with this. So click on OK. We get this values along with the chart outputs. Now if you observe, these values will be placed. Generally the value was in between. This 63.5 was in between 72 and 73. So if you find the average between these two, it will start from 73. So this value, if you delete, so we get the centered moving averages. So we get this centered moving averages. So this is the required moving averages trend values. So only the centered values are important. So we get only the 4 values, the first 2 values and last 2 values will be avoided in the moving averages. That is the main drawback of this moving averages method. And the corresponding trend line also we get here. If you observe, this blue color is the actual line that indicates these values, and also this red color is the trend line. So this blue color indicates 4 years moving average trend line, and this maroon color, that is the actual, that is centered moving averages trend value. So in this way, we find the trend values. So today we have discussed about the trend values by least squares method, where we have done the straight line and parabola also. So straight line equation. So from the given values, first go to scattered, insert scatter, then from the scatter plot, select any point, any type of chart, click on right click on any point, then click on add trend line. So and choose the required curve equation, that is, it may be straight line, parabola, power curve, or anything. Then write your equation clearly by substituting the values of different values here, that is different dependent values, we get the trend values. Now coming to determining the trend. So for your data, you have to remember, you need to have the data analysis, that is this. If you don't have, add in from the add Excel add-ins option. So we want the trend value. So I have added the chart output also here. If you don't want the chart output, it's okay, but it will be good if you draw the chart output also. So moving averages, you have to select your input range. You have to select the period of moving average and the output range and the chart output. Then your moving average values will be displayed. Then you need to check where to place that moving average values. It will be difficult only for the if the period of moving average is even. First, we calculate the even order moving average values. Then we find the centered moving average values by considering the period of moving average as 2. So this is the practical related to determining the trend to the time series data by the least squares and moving averages method. In the next class, we'll see how to determine the seasonal indices. So practice this